Okay, so I'm wearing a slightly different hat now. I'm wearing the hat from kind of software expertise. So if there's two things to remember from my presentation now, they're on these next two slides. The first thing to remember from doing 20 years, I've been involved in the software industry for about 20 years. And the first thing to remember is this, the first thing that we've learned is this, that we've learned a whole load of techniques and ways of working and tooling that allows us to make unambiguous specifications and execution instructions. And that's incredibly powerful. So it's not just like the blueprints of old, if you like, a blueprint for making a machine, done out very, very carefully on printed paper. We're talking about something from which the specification allows you to execute it. So there's a huge amount of ambiguity that's been reduced by specifying things in a digital format. And there's lots of other things that fall out from that. The second thing we've learned really from digital is it's important to optimize to make people engaged and empowered to build these systems. And I'll explain what I mean about that a little bit later. So I'm head of consulting at Conflux, and I've written or contributed to 3 books recently. I'm actually writing a couple more on software systems, which cover a range of aspects on how we build software systems and make them more effective. I've also got a bit of a conference habit. So I speak at conferences. That was me in London in a Velocity conference last year. But I've, for the last 5 years, been running a conference called Pipeline, which is focused on practice we call continuous delivery. And obviously, we've got Assembly Conference coming in October. Some recent clients that I've been working with, Call Credit here in Leeds, second largest credit reference agency in the UK. Dyson, obviously they're manufacturer, but increasingly now moving into the digital space. Huawei in China. ITV, LexisNexis, and I did quite a bit of work for Trainline. So what we'll learn today is kind of based on some of that experience. And the key 4 points are these. Because we've, through software, been building global systems, increasingly in the last 10 years, certainly 10, 15 years, systems are of a huge scale. There's things we've had to develop to enable us to deal with that, which have been very, very useful from an engineering point of view. We also have learned some agile ways of working, which turn out to be very, very effective for all sorts of contexts, not just software. We're now seeing agile practices move into finance and kind of legal spaces inside organizations and into marketing and other areas too. It's incredibly powerful. The way in which we can collaborate on code is incredibly powerful and is driving a huge driver for innovation. And the way in which we kind of deal with people is incredibly important for building stuff too. Anyone know what this is? Here's a loom. It's a jacquard loom, and this is a photograph of a machine in Armley Industrial Museum, which is about a mile down the canal. And it was built in commissioned in about, brilliant, thanks Claire, but commissioned in about 1880, something like that. And what you'll see here is the combination of manufacturing and code, because these punched cards define unambiguously the pattern that the jacquard loom is going to produce. So even back in 1894, we had a combination of manufacturing and code at work here in Leeds. So what have we learned from this global scale of software we've been doing over the last 20 years? Some of the key things we've learned are that the system will be wrong. We will have built the wrong thing, or we will have built it in a way which is not quite right. That's fine if we design it to be upgradable, if we design it to auto-scale, if we design it to handle failures gracefully. If we assume we've got it right and don't design these things in, we'll be in for a problem. So these are some really, really key things that we've learned. We've got lots of patterns for making sure that we can evolve what we're building. So some of the key patterns around that we've kind of come across in the last 20 years are design for change and failure, dealing with resilience, deduplication, fault tolerance, these kind of things. And many of the patterns are specific to software, but many are actually applicable outside of the pure software realm. They apply to how we think about our organizations. So how you commission your suppliers in terms of deduplication or in terms of designing for tolerance. So when one supplier fails or doesn't deliver on time, you've designed your organization in a way which then allows you to deal with that. And we're able to do that because software is very, very malleable and easy to change. So we can discover these patterns very rapidly, but we can also work out, oh, that's interesting. That's an interesting pattern. Let's apply that more fundamentally to other parts of our organization. So what can we learn from agile ways of working? What we've learned in the last 20 years is that iterative delivery works very, very well. And iterative means we deliver something, a small thing that is valuable and interesting to the business. We validate that. We get feedback from the people who have asked for that thing. They realize, oh no, that's not what I wanted at all. I actually wanted something different. And we discover what is needed by iterating over it very, very rapidly. And so the way in which we design stuff enables us to show something working every day, every week, on a very short timescale. We're making changes that we can demonstrate to people who are paying for it, the business or the organization behind it. And that changes how we build things. We have to build them to be demonstratable, if you like, on a regular basis. And we expect to discover the effective solution over time. So this way of working is incredibly effective, particularly in situations where of novelty, where we're building something relatively new or discovering new patterns. And in this context, iterative delivery done well works incredibly effectively. It's hard to do well because it feels very different from the old style way of doing things, where you have the big design up front and then design it and ship it. But when it's done well, it works. We've also discovered some very effective patterns when using collaboration on code, on software. And a lot of this is driven through what we call version control, which is where we track every single change to a digital file, and then we're able to follow the full change history through the entire life cycle of that set of code or configuration. And the transparency this provides is an incredible driver for innovation, particularly when the code is open source, as we call it, on the internet, and people can collaborate in different ways. It allows us to reason incredibly powerfully about the kind of changes we've done or the kind of changes we need. And we can do all sorts of things like trigger some automation when there's a new set of changes and trigger a set of testing or deployment or something like that. And these capabilities, I think, are really fundamental to the way in which we'd want to drive digitization in manufacturing and making, because it's an incredibly powerful thing in software to have this ability to track the change to a very, very fine-grained level. And finally, I just want to talk a little bit about what we've discovered around empowering people as part of this innovation mix. The companies that are most effective in doing software development set things up so that the people building the stuff, building and operating these systems, are effectively co-creating the stuff with the business. So it's not about, we specify this thing, you build it, which is a kind of fairly traditional sort of manufacturing approach. Certainly in the 19th century and part of the 20th. The idea is that actually we bring together people with enough context and enough awareness and enough investment, if you like, emotional investment in what they're building, that actually we discover new stuff by empowering and kind of engaging everyone in the process. And that is an incredible driver for innovation as well, because you're using those people who've got the skills and got the awareness and the thinking to say, well, actually, there's no point us building it like this. This thing over here is happening in the industry. Let's actually change how we build it, or discover if we should change how we build it in a different way. This is a kind of bizarre, interesting demonstration. We've got Windows trying to update my laptop here. So it's been designed for continuous update, which is possibly not always the best thing, at least in terms of how they've implemented it, but that's a separate story. Another thing that's really key is bringing live telemetry. So when I say live, I mean from production, from working live systems, bringing that telemetry, metrics, log data, how the system is working, bringing that information back into the teams that are building and running these systems to enable them to get a feel for what's happening in how these products are working. And we've now got the network connectivity and the kind of protocols and the technology to do that effectively at scale. And we're at the point now where we can do this for connected devices, IoT or industrial control systems, and so on. Bring huge amounts of rich telemetry back into the teams that are building and running these things to enable them to do that much better. So it's like, imagine you're on a ship. It's like you can feel the hum of the engine. You can feel how the ship is moving to enable you better to help build it better. We've also discovered some interactions between the shape of the organization, particularly the communication structure within the organization, the communication patterns in the organization, and some constraints on what we're actually able to build. So in 1968, Mel Conway observed that there was this constraint on organizations that build systems are constrained to produce designs which are copies of the communication structures within the organization. And because in software we're able to iterate very, very quickly, we've actually been able to substantially validate that. It's been spotted as well in other industries, automotive, aerospace, some other industries too, that we need to think about how the organization how the communication structures in the organization interrelate, because that will strongly drive the effectiveness of what we build in terms of the component interfaces and that sort of thing. So this is why making sure that the people who are helping to build and operate this stuff are engaged and empowered in the right way. So the system is effectively socio-technical. This is what we're talking about. We're building a system that includes people and includes machinery, and it's the combination of these that helps us to drive innovation at this kind of pace. I've just got a few examples. So we've seen the Jacquard loom. Here's a Raspberry Pi, which I think it's fair to say sort of really jump-started a whole lot of innovation in this space several years ago. This is mine that I bought there the other week. And we've got things like this from Pimeroni. They've got a nice little starter kit. And there's lots of other companies doing incredible innovation around the edge. You can buy little plugins to these devices, allow you to connect temperature sensors and motor controllers and all sorts of things for almost no money. I mean, for an incredibly small amount of money. This is an amazing amount of innovation and pre-built stuff which enables people just to get on and build things really, really really straightforward way. This controller here is called a crumble controller. It's even more simple than a Raspberry Pi. In this particular case, this is I was at one of Claire's workshops, and I was trying to draw some stuff with one of these little robots. And the controller itself is incredibly small and very cheap as well. And this is what the source code looks like. Don't worry about the detail, but you can just actually see that to write code for these things is actually quite, you can do it in quite a friendly way, because you can drag and drop these little blocks telling the robot what to do. You don't need to learn how to code before you can actually start to make one of these things work. So we've now got to a point as well where the way in which you interact with some of this technology is very, very straightforward and very accessible. And then moving into slightly more manufacturing industrial scale, these are some sensors from a company called IFM Electronics. And the interesting thing about these is that, so these are digital sensors, and we can retrofit them to existing kit. But the interesting thing interesting thing here is that these sensors have an identifier in them, which means that if one of the sensors fails, we can swap out the failed sensor for a new one. But the control box, which is sort of sitting there somewhere, recognize it as the same kind of sensor and can push down the configuration parameters immediately, so that, contrast that to the situation in the past where a human operator would have to go and manually enter the configuration parameters again. So this is sort of like it's the kind of pattern that we'd expect from a software world, and we're now seeing it coming into kind of manufacturing, where it's effectively we're pushing down the digital parameters down directly into the device, really shortening the time it takes to bring that system back up again into a working state. And we've got systems from companies like Bosch Rexroth. This is a really old but still working, well, it's a demonstration system, but let's say it's a lathe. We can add in sensors, digital sensors into this, bring them out into an IoT gateway, and then scrape that data, pull that data off what is quite an old system. Perhaps it was built in the 1930s or 50s or whatever. We can scrape all that sensor data off into the cloud, analyze it, and look for performance improvements in how we're using our machinery. So it's incredibly exciting time. All these things coming together, which is the point of this event today, an assembly conference. So that's all I have to say. These four things really. So we need to expect to design for change and failure. We should be aware that iterative delivery works if we get it right, if we design our systems in the way that enables it. We should expect to design things for version control, because it's incredibly powerful, enables us to do all sorts of stuff. And we should see the system as socio-technical, a combination of humans and machinery. If you've got any questions, feel free to drop me an email, Matthew@confluxdigital.net. Hopefully it's been interesting, useful to kind of set the scene.